Section 4.4, linear inequalities in two variables. So in this last section on the page, we're going to look at graphing inequalities, which is actually just like graphing equations, as if it was an equal sign, except for the difference that it doesn't have an equal sign. It has one of the four inequality symbols: greater than, less than or equal to, less than or equal to. So we can pretty much treat it the same as an equation. Treat it as if it was an equal sign there in order to draw the line that represents the equation. However, that whichever of the four inequality symbols you have also tells you whether it is going to be a solid regular line or a dashed line. And also, because an inequality doesn't just give us one, a certain amount of possible solutions, it gives us an infinite amount. So really, we're either going to be shading above the line that we draw or below the line that we draw, indicating that that whole area we're shading, all of those ordered pairs that fall in that shaded area are considered solutions. So let's look at an example of this. Our example here is to graph the inequality 3x plus 2y is greater than 6. Now, if this was an equal sign here, rather than in a greater than symbol, you'd want to think, well, what would be the best method to graph that equation, to graph that line? And in this example, because x and y are on the same side, that is in standard form. And the way we talked about graphing equations that are in standard form, an easy way to do that is by finding the x and y intercept, and then just drawing a line through them. So if we recall how to do that, to find your x-intercept, well, we know on the x-axis our y-coordinate is always going to be 0. So in order to find our x-intercept, we put in 0 for y into that equation and see what our x value would then have to be. So 3x plus 2 times y, which is, we're going to put in 0, and we just treat it as if it was an equation rather than the greater than symbol. So equals 6. Putting in 0 for y cancels out that y term because 2 times 0 is 0. So what we're left with is 3x equals 6, which is a pretty simple equation to solve for. Divide by 3 on both sides. And we get that x equals 2. So that right there gives us the x-coordinate of our x-intercept. So we can go ahead and plot the point, 2, 0. Okay. So we have 1 point on our line. Now we need to do the same process, but the opposite, in order to find the y-intercept, to find one more point on that line. So to find our y-intercept, we know the same thing is true. On our y-axis, any point that lies somewhere on that y-axis is going to have an x-coordinate of 0. So, using our equation up here, we put in 0 for x and determine what does y have to then be. And again, let's just treat it as if it was an equation. So equals 6 rather than the greater than 6. Putting in 0 for x cancels out the x term. 3 times 0 is 0. So we're just left with 2y equals 6. And again, we can solve that pretty easily. Divide on both sides by 2. And we get y equals 3. So we now know our y-coordinate of our y-intercept. So we can go up here on the y-axis, plot in a point there at 3. So that's the point, 0, 3. Alright. So right now we have 2 points. We know pretty much what our line is going to be. It's going to be the line that crosses through those 2 points. However, at this point we have to look at the inequality symbol that we had in the problem and use that to determine, is it going to be a solid line or a dotted line, a dashed line? And are we supposed to shade everything above the line or shade everything below the line? So is everything above the line supposed to be considered a solution, or is everything below the line supposed to be considered a solution? So looking at the inequality symbol that we had, we are going to look back at the original problem. It's greater than symbol. Okay, a greater than symbol tells us we're going to have a dashed line, and we're going to shade everything above the line. So dashed, and shade everything above. So when we draw in our line, we're not going to draw a regular solid line. We draw it in pieces. But it's still the same line that would cross through these 2 points. So there's our dashed line. You can see it's not completely solid, but we also have to determine shade everything above that line or below it. So above, because of the symbol that it is, tells us to shade above. A line like this, to me, I guess, when I say above, it seems kind of intuitive. Everything above would be everything kind of to the right of this line. Below would be everything to the left of the line. So if that makes sense to you, go ahead and use that logic. So you'd actually shade everything kind of above and to the right of this line. In every single quadrant, doesn't matter. If it's to the right of the line, we shade it in. So it'd be all of this. And what this means is that any given ordered pair we can find that's in this shaded area I just drew in, that ordered pair is going to be a solution to this inequality 3x plus 2y is greater than 6. For example, if I picked the point over here, 8, 2, something like that. Well, if we did 3 times 8, our x-coordinate would give you 24, plus 2 times 2 would give you plus an additional 4. 24 plus 4 would give you 28, and that indeed is greater than 6. So any point that we pick over here, if we plug in x and y into this equation, or inequality, it's going to give you some value that's greater than 6. If we pick a point over here on the left, it's not going to give you a value that's greater than 6. And that's actually another way you can check which side should you shade on. A way I like to do it is if your line doesn't cross through the origin 0, 0, okay, right there, you can use that point to check. And that makes it really easy because 0 cancels things out. So let me kind of come here on a separate sheet and show you what I mean by that. If we have 3x plus 2y is greater than 6 is our original problem. If we put in 0 for x and 0 for y, because we're going to check the point 0, 0, well, 3 times 0 plus 2 times 0, we're going to check, is that greater than 6? Well, this is going to give you 0 and that's going to give you 0. So we're actually asking, is 0 greater than 6? No. 0 is less than 6, obviously. So that tells us the point 0, 0 should not be shaded. Okay? So going back to our graph, you can see 0, 0 is on the left side of our line, and that was not shaded. Everything to the right was shaded. If 0, 0 would have given us a situation that made sense, then we would have wanted to shade the portion that included the point 0, 0. So that's another way you can determine should you shade to the right or left of the line. And that right there is graphing inequalities, section 4.4.